Hi everyone. Today what we're going to work through is we're going to take a little bit of a different turn. We've now spent a number of days going through and graphing lines. We've spent a little bit of time talking about a slope coordinate formula. And then we spent a little bit of time talking about some parallel and perpendicular lines. Now what I want to do is I want to spend today going through and talking about how do we actually build the equation to a line. So we're going to move away from a lot of that graphical stuff and we're going to really get into some algebra today. I'm going to say that I think today's lesson, if I had to place it in terms of level of importance, we're easily top 5. That you having the ability to build the equation of a line is going to be something that you're going to draw from for the next number of years. Okay, so let's jump into it. So what you see in question 1, that's going to actually be our instruction for the entire day. That we're going to determine the equation of the line with the given properties in each case. So what I'm going to do today is I'm going to throw certain properties at you. They're all properties of lines. And what we need to do is to be able to take those properties and create the equation of the line that would produce that. So let's take a look at the first one. You have to give me the equation of a line that has a slope of -2 and a y-intercept of 5. So what I want you to do is to work on that one and you come up with the equation for that one. Let's pause the video now. Okay, and we should be back. So I'm going to hope that you guys looked at that question and you thought, okay, this one's straightforward. Because we know that all lines can take the form y equals mx plus b, and we know that our slope is the m, and we know that our b is the y-intercept. And so therefore, what we could have done is we could have just plugged that information in, slope -2, y-intercept of 5, and we are good. So hopefully we match up. Nice and straightforward on the first one, and that gives you a real good gauge as to do you have that form of an equation of a line from the past. Okay, let's take a look at the next one. Now I want you to work through B. So you need to build the equation of the line that is parallel to the line y equals 3x plus 2 with a y-intercept of -1. So same thing. I want you to go ahead, pause the video, come up with that equation. Pause it now. Okay, and we're back. So, if we know that our lines can all take the form y equals mx plus b, then if we knew the slope and we knew the y-intercept, then we could create that equation. Well, I could start to build that equation right now because I know that I need to have a -1 as my constant, because that's my y-intercept. However, what I'm missing is the coefficient on my x. I'm missing the slope. If I knew the slope of the line, then I could build the equation. Well, if I look at this information up here, it tells me that I have to be parallel to that line. Here's where we need to draw back on old information. What do we know about parallel lines? If lines are parallel, then that means they have the same slopes. And so what I need to do is I need to be able to recognize, well, what is the slope of y equals 3x plus 2? And if we can recognize that it has to be my coefficient of my x, then all I need to do, yikes, is fit in my slope. There we go. Hopefully not too bad. Okay, I want you to jump into C now. Build the equation of the line that is perpendicular to that line and has a y-intercept of 7. Okay, give that one a shot, create the equation. Let's pause the video now. Okay, and so we're back. So, I wanted to throw problem C at you because I think that there's a real common mistake we can make. It's a mistake in theory, but we just have to be very careful that our thought process on it isn't entirely a bad thing. So if we recognize then that we've been given our y-intercept, and so we know then that we could write the equation as y equals something x plus 7, well then what we're missing is slope. Now we see the key term here that we are perpendicular to, and hopefully we recall that perpendicular slopes have to be negative reciprocals of each other. Here's where we make our mistake. We say, well then the slope of that line is the coefficient on my x, so the slope is 5. Be careful. I can only read the slope of a line if my line is in slope-intercept form. Which means if I was to take that line and rearrange it, that is, isolate my y. So let's get the y all by itself. Well, now maybe I can see that my slope wasn't 5. So if we stayed away from that mistake, then I think we're doing great. I'm just going to slide that up a little bit. Here's how we write our notation. On that purple line, my slope is negative 5/2. And so when I draw my conclusion then, I can say, therefore, the slope that is perpendicular. And so I draw in my little 90-degree symbol. The slope that is perpendicular is change the sign so it's positive and flip my fraction. There is my negative reciprocal. And now that I know what the slope of the line I'm looking for is, make sure that that's our coefficient on our x, and we're doing great. So if we got down to that red equation of y equals 2/5 x plus 7, then I think we're doing great. Okay, things are about to take a turn. Let's take a look at the next question. I want you to notice what part D asks you for. It asks you to determine the equation of a line that passes through that point and with that slope. And so what I want to do now is I want to go through this problem, because what we're going to do is we're going to kind of pull back a little bit what we've just done in the first 3 parts. And we're going to examine building the equations of lines in a very holistic way, a very generalized way. That's going to require us to consider a little bit in terms of theory. And then I want to go through 2 different ways to do it. And I think once we've done that, then it's just a matter of knocking out a little bit of practice and seeing some of the quirky little things that could occur. So I want to move away from question D for a second, and I want to talk about some stuff just in general terms. So as we go through to build the equation of a line, I hope that there's a couple little concepts that we can reason out logically. Like, I might have a grid somewhere, and I'm just going to put on like a quick set of axes. And if I asked you, well, what information do we need to know to be able to build the equation of a line? That is, to be able to have only one line with those properties. Then my guess is I would have a bunch of people that would tell me slope. I need to know the slope of a line. But I just want to draw your attention to the fact that slope of a line is not enough. Like, that is, if I asked you, okay, well, the slope of my line is 2. There you go. Now we know it. The slope of the line was 2. Are we good that there are infinitely many lines that could have a slope of 2? There are infinitely many lines that could have that slant to it. So just knowing my slope wasn't enough to nail it down to the one particular line it must be. Now, the other part that we might say then is, well, yeah, but like if you knew what the y-intercept was, and I'm going to argue to you that the y-intercept is important. but I think we need to make it a little more general. Are we good that if you knew a point that a line passed through, it doesn't have to be the y-intercept, but just a point. Let's say that my line had to pass through that green point. And all you were told was that it had to pass through the specific point. Are we okay then to come together with an idea that there would be infinitely many points that would pass through that green point? Like I could draw on a blue line that goes through the point this way, but maybe it's a blue line that goes through the point this way. Maybe it should be this way. Maybe it should be this way. Are we good that now we could see that there would be infinitely many lines that could pass through that one point? That there is only one line you could draw if you knew both the slope and a point. That is, if I told you that your line had to pass through that gold point, and it had to have a specific slope through it, then if I give you both of those pieces of information, then there is only one line that could match both. And so as we progress through building the equations of the line, I want it to be almost reflex for you. That if I was to ask you the question, what information do we need to know to build the equation of a line? You're going to tell me slope, and you're going to tell me a point. Now, there isn't a hierarchy of order there. So I could have called that like 2 and 1. They are both important. They are both needed. If you look back to your solutions on questions 1A through C, you'll notice that what I actually gave you was the slope and a point in each problem. Now, it happened to be a very specific point. Your points, in each case, happened to be the y-intercept. And because it was the y-intercept, that meant it was really easy to build the equation of the line. Maybe I didn't give you the specific slope, but I gave you information about how you could find that slope. For instance, using parallel and perpendicular. But if I ask you, what information do you need to be able to build the equation of the line? You need to go slope and a point. And if we have that information, then I only have one possible line that could match that criteria. So let's jump back and take a look at problem D. As we take a look at D now, notice that I have given you a point and slope. Now, what I'm going to do is I'm just going to draw in a quick picture. You do not need to do this. And in fact, in most cases, I don't want you to do this. But just for us to recognize that if I was to put a point at 4, 3, so maybe I'm over here somewhere, and a slope of 2, then there is only one possible line that could ever be created that passes through point A with a slant of 2. Any other line I went to try to draw would have to have a different slope to it or would not pass through that point A. So what we need to do now is to try to build the equation that would give us that red graph. Okay, here's method 1, and I'm going to walk through a method that I think will be relatively straightforward. I want to be clear, this is not the way I would go through and solve this problem. However, I think it would be a way that I think would make the most sense right now. Okay, here we go. I know that all lines can be written in the form y equals mx plus b. And so now what I'm on the hunt for is to be able to plug in an m value and a b value, and then I could have my line, just as we did for the previous 3 problems. So I'm going on the hunt to find what m is and what b is. Now, the nice part is I was told what the slope was. It's a slope of 2, so I know that my m is 2. But I don't know what the y-intercept is. Now, just for argument's sake, can we look back at the graph and realize that we would be looking for a negative value? We can see that our red graph is going to have a y-intercept that's somewhere negative. Okay, good. Now, how can I go about finding that? And I am not using my picture. That there is something that I think a lot of us don't fully get when we start to look at what y equals mx plus b is. That we actually just look at that as almost like a formula. Like we can regurgitate it, but do we really understand what it says? And what that equation actually represents is a relationship between points and slope. I'm going to circle your 2 points, or highlight your 2 points in that equation. We should all be good that b represents a point in that equation. It's a very specific point, y-intercept. But we should also recognize that this y combined with this x also represents a point. We know all points take the form xy. You know that that represents a point because you know how to build a table of values. You would pick an x value, you sub it in for the x, you calculate everything, and it spits out its y value. So what that equation actually becomes is a relationship between a generic point and a specific point. So what we're going to do is we're just going to use the generic point within that relationship. Okay, so what I can do is I can sub in my m value of 2. We knew that right off the bat because we knew slope was 2. But what we can also do is we can sub in our point. Notice point A has the coordinates 4, 3. That means that the x value is 4 and the y value is 3. So in my equation, I could sub in an x value of 4 and a y value of 3. Okay, here's me subbing it in. Replace my y with 3, replace my m with 2, replace my x with 4, plus b. Now I hope you can see my mistake in that red line. If I go back and look at my equation, it's m times x. There's a multiplication between those 2 things. And the way I just wrote it in my red makes it look like it was 24. So when we sub in for that x, let's make sure we put brackets around it to make sure that we can still see the multiply operation. Okay, I want you to take a look at that red line because that's very important to us. Do you notice that you have an equation? You have numbers on both sides of the equal sign. How many variables are in that equation? Just one, your b value. And wasn't that what we were looking for in the first place? So let's go ahead and let's solve that equation for b. So I'm just going to get rid of some of that red arrow and that red star. I'm going to solve that equation for b. I don't like that 3. 2 times 4 gives me 8. To get my b all by itself, get rid of a plus 8, so I'm minus 8. And there we go. So what were we actually looking for? We were looking for a y-intercept, and we actually found that that y-intercept would be at -5. Okay, the only thing we haven't done is actually write the equation of the line, so let's write it. So I could then say, therefore, y equals slope of 2, y-intercept of -5. And there we go. That is how we can use y equals mx plus b to build the equation of the line. I'm hoping that that was pretty understandable. It was pretty logical. We just didn't think maybe that we could use y equals mx plus b in that way. Okay, what I want to do now is I want to show you the way I would go through and build this equation of the line. It's going to look a little uglier. I'll fully admit that. It's going to make you go, why would you do this the uglier way when we could have just done it the old way? I'm going to ask for your patience a little bit as we move through this different method. Okay, here we go. So what we're going to look at is the exact same problem. I don't think we need the picture. You have that in your notes now from the previous problem. Okay, we just talked about one equation that represents slope and 2 points. Well, you have another equation that represents slope and 2 points. It's your good old slope coordinate formula from yesterday, or from a couple days ago. I want you to notice that that relationship is also the relationship of slope and 2 points. We got enough practice with going through and plugging numbers in to calculate slope, but what we can also do is we can use that relationship to build equations of lines. The same way as y equals mx plus b is the relationship between slope and points. So I'm going to get rid of all of that mess. And what we're going to do is we're going to jump in and we're going to use our slope coordinate formula to build our equation. So maybe we're still at the point where we are writing down that formula to drill it in. Okay, what do we see in this? Now, I don't want you to copy this down with me because I'm going to erase a little bit from this solution. But this would be me going through and subbing our stuff in. We should be good to see that my m is still 2 because my slope is 2 given in the problem. And now what I can do is I can say, well, the point A, 4, 3, wouldn't just be like xy, because when I look in my blue formula, I notice I have 2 different points. So maybe what I do is I call that one like my x1 and y1. That would be my point 1 because it was one of the points that I know. So what I could do is I could replace my x1 with 4 and replace my y1 with 3. Now, this is what I say about don't copy this down yet. Because what that would give me then is a slope of 2 equals y2 minus 3 over x2 minus 4. And here's where I'm going to say that there's some stuff that I just wrote down there that is not needed. Notice, we needed these little subscripts up in our original formula because I needed to tell the difference between my y's and tell the difference between my x's. But when you look at my red version right now, I don't need these 2's anymore, because I don't have multiple y coordinates or multiple x coordinates in that equation. There's only one y and there's only one x. So let's not even bother writing down the subscript. Like, let's get rid of that little 2 in there. And then let's get rid of this little 2 up in here. I like that better. It's a lot neater to see. But it's also a case where you're looking at it and going, okay, that starts to look a little less less spread out. There's less notation there. It's more understandable. Okay, let's take a look at that line because we should recognize that that doesn't look like the form of any line we're used to. Okay, here's where I need to give you some guidance as to where to go next. For us to build the equation of the line, we have to get rid of, we have to get rid of this divide by x minus 4. So how do we get rid of a divide by x minus 4? We multiply by x minus 4. So what we're going to calculate then is going to be the 2 times our x minus 4, and that's equal to y minus 3. Okay, I'm hoping most people's instincts are going to take over now, and you see the brackets on the left side, and so we choose to expand. Now, I'm going to argue as time goes by, most of you are never even going to have to write this line in, that you'll look at the divide by x minus 4, and when you multiply it out, you go straight to an expanded form. Okay, now if I want to rewrite that and I want to get the y all by itself, I need to get rid of my minus 3, which means I need to add 3. And so I have y equals 2x minus 5. And you'll notice we get down to the same thing that we did before. Now, it begs the question, then why is this the way that you would choose to do this? And the reason for it for us is there are multiple forms that we want to put lines in. Like, yes, we have y equals 2x minus 5 as a form for y equals mx plus b. That's one form of a line. But we also have a form of ax plus by plus c equals 0, which is our standard form for our line. In some cases, you'll even see that written in this form where the constant is isolated. As you guys progress through math, you start to see standard form probably more often than what you see slope-intercept. And so, for us to build standard form, right on this line, I can just decide how I want to move stuff to put it into one form or the other form. The second thing you're going to see is using the first method on this problem was really direct because my numbers were super nice. When I highlight those numbers, look at the numbers that we subbed in. 2, 3, and 4. Well, we've spent a bunch of time dealing with slopes that were fractions. We've spent a bunch of time dealing with some coordinates that can get pretty ugly. As your numbers get uglier, you might find that this method becomes more efficient. So what we're going to do is we're going to walk through with this uglier method, and we're going to get a little more practice with it. Okay, here we go. So let's take a look at problem E. I'm telling you now that it passes through point B, which is at negative 3, 4, and has a slope of negative 2/3. Okay, I don't think we're ready yet to build equations of lines on our own. So I still want to do this one using both methods. So I need to be very clear that if I ever asked you to build the equation of a line on an evaluation, and I will ask you to do that, you don't give me two solutions. Just give me one. But I'm going to walk through this using both methods. So let's take a look at that first method. Y equals mx plus b. So what I could do is I could replace my x, y, and m with the appropriate values. So I'm going to replace my y with a 4, my m with a negative 2/3, my x with a negative 3, and I don't know what my b is. Okay, well now we need to solve that equation for b. So it's really nice that we see that our 3's are going to divide out. And so now we can work our way through and we get a 4 equals negative 2 times negative 1 is a positive 2. And we get a b value of 2. So we can go ahead then and we can write our equation that had a slope of negative 2/3 and a y-intercept of 2. Okay, I just want you to take a look at that equation, and maybe you can see that that process worked out really nice again, but because we were able to cross-reduce. So can we start to imagine maybe how uglier that problem would have been if those 3's did not divide out? Okay, we would have taken negative 2/3, multiplied by a number, which means we're going to get a fraction. Now, when we go to isolate b, we would have to get a common denominator. And as soon as we have to get common denominators, I'm going to bet and say most of us slow down. Like we should. Most of us are going to be a lot faster to work with integers than we would be to fractions. So notice that the numbers worked out really well, but that could have been a little uglier. The second thing I want you to notice is look at what the instruction was for today. It was determine the equation of the line. And I want you to notice that most of your work in this process wasn't determining the equation of a line, it was you finding b. That maybe using our other method is more direct. And so what we're going to do is we're going to tackle this problem the other way. So my slope could also equal y2 minus y1 over x2 minus x1. There is another relationship between slope and points. So now I can go ahead and I can sub in my information. My slope is negative 2/3. And now when I view that point, I can view that as x1, y1. I'm going to have y minus 4 over x plus 3. And we all see why that was a plus 3 on the denominator now, because I was taking x subtracting a negative 3. Okay, I get to that point and that looks even uglier than before. However, we can get rid of all of those divide bys. Like, how do we get rid of a divide by 3? Well, we multiply the other side by 3. How do I get rid of a divide by x plus 3? Well, I multiply the other side by x plus 3. We should be able to see on the screen why our next step is going to be to cross multiply. So I'm going to take my negative 2 and I'm going to multiply it by x plus 3. That's equal to, make sure you have an equals in there still, it's still an equation, my 3, and I'm going to multiply that by all of y minus 4. Now, if we get some practice with this, you're going to find that you're probably going to skip that step. That if you look back up at the previous line, you could see that you're going to have to take negative 2 and expand it into all of x plus 3. So it's negative 2 times x, negative 2 times 3, equals. Now you're going to take the 3 and you're going to have to expand it into all of y minus 4. So you're going to have 3 times your y, and then 3 times negative 4. We come in on that line, and we can match up pretty quickly with the blue. So maybe what we do is we say, let's get the y all by itself. Well, that means I have to get rid of this minus 12, so I'm going to add 12. So I'm going to now have negative 2x plus 6 equals 3y. And now I have to get rid of that 3 that's out in front. So to get rid of a times by 3, I'm going to divide by 3, and I need to divide everything by 3. You notice we come in, we are lined up, we're good. However, maybe I wanted to take that line and I wanted to put that in standard form. So I want to put it with all my terms on one side of the equal sign. Then what I need to do is I need to make sure that my x coefficient is positive. So I'm going to picture everything going to the right side. We should be able to see that if I moved my x term to the right side, it would become a positive 2x. So how do you get rid of minus 2x? We add 2x. I got 2x on the right side. I already have the 3y term on the right side, so it stays the same. And now I have to get rid of a minus 6, so I'm going to add 6. And since everything's on one side, then it's equal to 0, and that would be an example of standard form. As you move throughout your math, you're going to see more and more of the red form. And maybe you can see why that's a little bit easier to work with. I want you to notice that regardless of how nice and neat or how ugly the numbers are in that green method, the second we cross multiply, my fractions are gone. So I never have to worry about getting a common denominator and dealing with some uglier numbers. Okay, you're going to see me use that green method more and more. So let's try another problem. Okay, I'm going to throw into you guys that I think this should be a challenging problem for today. As you guys deal with equation of a line 2 on the next day, this is going to be an ordinary problem for us. Today it's going to feel challenging. What I want you to do is I want you to try to go through and build the equation of that line. We recognize what information do you need to build the equation of the line. I can almost hear you screaming it at home. Slope and a point. So what information was given to you? The point. That means you need to find the slope. So I want you to try to finish off this problem building the equation of the line, and we're going to see if we match up. Okay, let's pause the video now, give it a shot. Okay, we're back. So if we recognize that we had the point, then we had to go on the hunt for slope. Well, you were given this equation, and you're told that we need the line that's perpendicular to it. Well, if we recognize then that the slope of this line is 5/2, then my perpendicular slope has to be the negative reciprocal of that. Switch the sign and flip it. Okay, now that you have slope and a point, we should be able to build the equation of that line. So I start off and I know that I have my slope coordinate formula. Slope is y2 minus y1 over x2 minus x1. That is, you guys know that so well by now, you don't even have to write it down. Come in on your first line of your slope, y minus 4 over x plus 5. Now, hopefully that matches up with your solution. And I'm going to give everybody an opportunity to go through and write this one in standard form. That is, everything on one side of the equal sign. Okay, I want you to pause the video now, give it a shot. Okay, we're back. So I would love it if our next line was this. I would love that. But I also don't want you to think that you have to be there right now. That is, I think it's okay for today especially to write that line down. To see that we need to get rid of this divide by, so we're going to multiply it out, which gave us that. And then we have to get rid of this divide by, so we're going to multiply it out, which gave us that. But notice you can jump straight to the expanded version on both sides. Okay, now that we have that, I can put that in standard form really, really fast. My x value needs to have a positive coefficient. Right now, it's got a negative coefficient, so I need to picture everything going to that side. So, on that side, the right side, I'm going to have a positive 5x. The 2y is already over there, so I don't have to worry about moving it or changing its sign. It's still at a positive 2y. And now I need to get rid of this negative 25, and so to get rid of a minus 25, I need to add 25, and that gets us to positive 17. Everything's on one side, so it's equal to 0 on the other side. If we got down to that, then I think we are doing great for today. Great for today. However, you didn't have to put it in standard form, like I asked you to early in the problem, but if I asked you this question on a test, then I would have a bunch of people that would take this line right here and they would go in a different direction. That instead they're going to say they're going to get the y all by itself. So my 2y is on one side, my negative 5x is on the other side, and I now have to get rid of a minus 8, so I'm going to add 8. Now I have to go through and I have to get rid of my times by 2, and so I'm going to divide everything by 2. I get a little confirmation that yes, my slope is negative 5/2, and now there's my y-intercept. So on a test situation, I would not care whether you gave me the green final answer, so what I just highlighted in purple, or the blue final answer, what I just highlighted in purple. Either one is great. Okay, so I think what we need now is we need a problem to just be able to challenge ourselves and see, okay, do we have what we need from today? So let's jump into the last problem for today. You take a peek at what you have on the screen. Let's use this one as a gauge. So I want you to go through and try to build the equation of a line that passes through that point and is parallel to that equation. Okay? I'd like you to try start to finish and see if we can come up with the same thing. Okay, so pause the video now. Okay, we're back. So what information do we need? We need slope and a point. Well, we have a point given, point D. We need to find slope. Well, the nice thing is you were given the equation of a line, so we can find the slope from that. What we need to do, though, rearrange that line. So let's get rid of the plus 4x. So there's a minus 4x. Now I need to get rid of my times by 3, so I'm going to divide by 3. In that purple line, I have a slope of negative 4/3. And so I know that my parallel slope, and you just see a little blown up version there on your screen, a little parallel line symbol. You don't have to show me that. My parallel slope then is the same, negative 4/3. So we are good then that what you need to show me, or sorry, what you found was that your slope was negative 4/3. And therefore, as we go through to build the equation of the line, you now need to build the equation of the line that passes through point D with a slope of negative 4/3. I think some people may have made a mistake up to that point, and I want to give them the opportunity now to try to finish off the problem. So, can you now build the equation of a line with a slope of negative 4/3 that passes through point D? Okay, pause the video now if you need to make any adjustments. Okay, we're back. So if we were comfortable with that, then I should have seen a lot of this on your page. That my slope is equal to y plus 1 over x minus 3. We're all good with why the top is y plus 1. I was taking y and subtracting a negative 1. So I really add. Okay, I've got that. Now, I would love if we could jump to this next line. Negative 4x plus 12 equals 3y plus 3. There is me cross multiplying. I get to that point, and who cares what form of line you put that in? Just put it in one or the other. So maybe I take that, and I go, okay, I'm going to get my y all by itself. That means I have to get rid of that plus 3. So I have a 3y is equal to negative 4x. To get rid of a plus 3, I subtract 3, and I got my 9. Now I need to get rid of my times by 3, so I divide by 3. And you come in on that red equation, and you are perfect. Maybe I had other people, though, who said, standard form's easier. I don't have to divide out anything. Then we need to look at the coefficient on our x. We notice that it's negative. So we need to get it all onto one side of the equal sign with my x coefficient being positive. So I'm picturing everything going to the right. That negative 4x becomes a positive 4x. My 3y was already over there, so it doesn't change signs. And to get rid of a plus 12, I need to minus 12. There is everything on the one side, so all that's left on the other side is 0. There we go. So I think we are doing outstanding if you got down to either the final red line or that green line for our equation. Nice. Okay, your job today is to jump in and get some practice. So we want to make being able to build the equation of a line from slope and a point as automatic as possible. We now love it when you gave us the special point, a y-intercept, but we're good to just deal with generic points with any coordinates. Okay, jump in and get some practice. You should be good. Okay, good luck.